So we'll be solving quadratic graphs. So these are questions, past questions. So we'll just run through them. So I want us to be as interactive as possible. So this is the first question. It says use a scale of 2 centimeter to 1 unit on the x-axis and 2 centimeter to 2 units on the y-axis. Draw the graph of y is equal to 2x squared minus x minus 4 or minus 3 less or equal to x less or equal to 3. That means the range of value for the x should start from minus 3 and end at 3. Then after plotting the graph, we have to use it to answer the questions that follow. So once you have a question like this, the first thing to do is to form the table. So you are told already that the value of x should range from minus 3 to 3. So what you do, given the quadratic equation as y is equal to 2x squared minus x minus 4, so you impute this value of x into that equation to get all the values of y. So are we together?
No, ma'am.
Hello, can you hear me? Hello,
Hear
can you
you.
hear me now? Okay.
Yes, ma'am.
So like I said, the first thing to do is to form the table of values. So I have a sample table of value here. So there are different ways of doing it. You could start this way. Just pick all the values in the equation. You pick 2x squared, and then negative x, and then negative 4. And find the values from minus 3, just as x is given from minus 3 to 3. So we use the value when x is minus 3. We put it into 2x squared. Minus 3 squared gives us 9. 9 times 2 gives us 18. Then minus x means what? Minus of minus 3, which becomes positive 3. That's how we get this value. And then negative 4 is just negative 4. So then at the end of the day, we add for this column 18 plus 3 minus just 17. Is this clear? Hello, are we together? Is this clear?
Yes, ma'am.
Okay, so same thing for minus 2.
Ma'am, please,
We
how
can
did you
immediately
get the 17?
18 plus 3 minus 4 gives us 17. And you add up this 17. So for the second one, it's just same as putting into negative 2. Now I'm working with negative 2 squared minus 4. So I'm imputing it in this equation, the quadratic equation we have here. So this becomes 2 times, first of all, we simplify negative 2 squared, that gives us 4. 4 times 2, that gives us 8. Then minus 2 gives us positive 2. And then we have negative 4. So that's what forms the values here. 8 plus 2 minus 4. So when you add this up, you have 6. Is this clear?
Yes, ma'am.
Okay.
Yes,
So
ma'am.
for the next one, we just impute negative 1 instead of negative 2. So negative 1 goes here. So you need to be very careful when forming your table because any missed value is going to affect your graph. So you need to take carefulness in plotting, in getting your table correctly. So negative 1 squared gives you 1. 1 times 2 gives you 2. Negative times negative 1 gives you positive 1. Negative 1. The same thing, so that's how you keep changing the values for x until you get to the last value, which is 3. So if you go on like that, now we use the value of x to be 0. So that will be 0 squared, and here 0. 0 squared is 0. 0 times 2 is 0. Minus 0, and then minus 4. So that gives us negative 4. So same way you impute 1. 1 squared is 1 times 2, that gives you 2. And then negative times 1 is negative 1. Then you have your negative 4. So 2 minus 1 minus 4 gives you minus 3. You do the same for 2, impute 2. So you have 2 times 2 gives you 4. 4 times 2 gives you 8. Then negative times 2 gives you negative 2, and then you have your negative 4. So when you add up the values in this column, you have 2. Same thing for 3. 3 squared is 9 times 2. That gives you the 18 we have here. Then negative 3 gives you negative 3. And then your negative 4. When you add the values in this column, you have 11. So now what is our y value? What are we going to plot? When x is negative 3, y is 17. When x is negative 2, y is 6. When x is negative 1, y is negative 1. And when x is 0, y is negative 4. When x is 1, y is negative 3. And when x is 2, y is 2. When x is 3, y is 11. So is this clear?
Yes, ma'am.
Okay, so maybe should I take a screenshot of the table of values so that we go to the graph to plot the graph, because that's the first question. They said we should use a scale of 2 centimeter to 1 unit, and then on the x-axis, and then 2 centimeter to 2 units on the y-axis. So the next slide I will show will be the slide that contains the graph of this parabola. So I'll give you just some seconds. Take down the table of value. You don't need to copy just the first row for x values and then the last row for the y value. Then we move to plotting it. And then the scale is very important. Once they give you a scale for a question, you have to use that scale. If you use a different scale, you lose the marks. You'll be penalized for that. So always, when it comes to graph, take note of number 1, your table of values must be correct, else you will not get the correct graph. Number 2, you must use the scale given in the question. So always look out. Every wire question, they give you their scale to use. So don't just go and use anything you feel like using. Always check what is the scale and then use it correctly. So I move to the graph now. As you can see here, we were told that on the x-axis, we should use 2 centimeter to 1 unit. And then on the y-axis, we should use 2 centimeter to 2 units. What does that mean? Now, if you look at my graph here, I have the big boxes. Each of these boxes, if you carry any graph like this and measure this big box, each of them gives you 2 centimeter if you measure it using your scale rule. So that means for the x-axis now, you see I started with 1 using the big box. This is 1, this is 2, this is 3, like that. And then at this point, of course, we know this is 0, then negative 1, negative 2, negative 3, just the number line we know. Now, what does this mean? 2 centimeters, since this big box, if you take your ruler, go and measure it and see, it is approximately 2 centimeters. So you see this big box is 2 centimeters representing 1 unit. So whatever it's representing, that's what you continue with. So after 1, I add 1 to get 2, like that. So you keep adding 1s. But on the y-axis, you see, same thing, one of the big box, but I started with 2, meaning what? 2 centimeters here is representing 2 units. So I'm grading the y-axis in terms of 2. So that's 2, 4, 6, 8. So the way you label your axis is very important. If you start with 1, that means you keep adding 1s. If you start with 2, you keep adding 2. If you start with 3 like that, it will be 3, 6, 9, like that. So this is also very important, else you won't get the correct value. And same thing, below the y-axis, you have -2, -4, like that. Is this clear?
Yes, ma'am.
Okay. So then to plot our point, the first one says -3 and 17. But now if you look at our graph, we don't have exactly where 17 is. So that's another thing you need to know when it comes to graph. Once you have your graph this way, as you can see, like I said, each of those big boxes is 2 centimeters. So even if you are confused, you can always approximately, you can always use your scale rule to measure to know what they mean by 2 centimeters. So how do I know what one line represents? Because now to locate 17, 17 is between 16 and 18. So the best thing is for me to know what one line represents. How do I know what one line represents? I look at the y-axis. I have that 2 centimeters is what is representing 2 units. But how many lines is this 2 centimeters? If you check it, if you have, I know what I am showing is not that clear, but if you look at it from this point down to where 2 is, we have 10 lines. So 2 centimeters normally represents 10 lines. If they ask you for 1 centimeter, 1 centimeter is just 5 lines, 2 centimeters is 10 lines. So that means 10 lines is what is representing our 2 units. So what will be one line? So it's good most times you know what one line is, so that if you are finding a point that is not part of the point you have demarcated, you can just know how to get that point. So if 10 lines is 2 units, then what will be one line? 10 lines is 2 units, so one line will be, of course, since the number of lines is reducing, you have to divide. So that will just be 2 divided by 10, which gives you 0.2. So meaning each line for the y-axis, because we started with 2. So each line for this particular question for the y-axis is 0.2. So how do I get to, I hope this is clear, right?
Yes, ma'am.
Okay, so how do I get to 17? Because the first point says 17. If each line is 0.2, I know that 0.2 times 5 gives me 1. So from 16, if I move 5 lines, I will get to 17, because that will be 16.2. The first line, the second line, 16.4. Then I have 16.6, 16.8, and finally 17. So I need 5 lines after 16. So it's not that visible, but so that was what generated this. If I count the lines from 16, that will be 1, 2, 3, 4, and 5. So that gives me where 17 is. So at -3, the y value is 17. Then at -2, we say the y value is 6. So that is already denoted on the graph. So we have that. Then same thing at -1, our y value is -1. So I locate it halfway from the origin to -2. Then going further at 0, so at this point, this is where x is 0 on this axis. X is 0 here. At 0, the y value is -4. So that's why I have it here. Then when x is 1, y is -3. So -3 is halfway between -2 and -4. Then when x is 2, y is 2. So when x is 2, I trace it up and I have this point, y is 2. And then when x is 3, y is 11. So is this clear?
Yes, ma'am.
Okay, so the next thing is to join your lines. So it's either you are using your French curves, or if you can manage to use your freehand, that's also okay, but you have to gauge the point to make sure you don't. So I'm trying to use my freehand here. Let me see. So most times when you are plotting your graph, start light so that in case you need to erase, start plotting light so that in case you need to erase, you can easily erase and your work will not be dirty. Okay, so if you need to erase, it's easier. Then maybe after getting your point, you can now, thicken it. So it's just best to start light and try to join your points. So I'm using my freehand here, but if you have your instrument, you can always use that. So you see, I'll have to erase. This part is not really aligning. So like that, I'm just trying to show you how you can draw even without the instrument. But if you have the instrument, no problem. But always draw light so that when you come to try to edit, so I'm just using my hand, so I don't expect this to be very perfect. So is this clear?
Yes, ma'am.
Okay.
Yes, ma'am.
So this is the one I drew, the same graph. So the one I showed you previously, I just enlarged it. So this is the graph after drawing. So this is what it should look like. So now we can go back to answer the question. So that's the first part of the question, plotting the graph and the table of values. So the B part of the question says, use the graph to find the roots of this equation. Now, if you look, the root of the equation they want us to find is just the equation we have plotted. So anytime you plot a graph and you are asked to find the root of that graph, the root of any equation is the value you get whenever you solve the quadratic equation. Now, when they say from your graph, they mean from your graph. If you go and start solving this, maybe using factorization or completing the square or formula method, it's going to be a clear 0. They don't expect you to go and solve this question. They expect you that from your graph you get it. So how do you get it from your graph? Now, anytime they say find the root of a particular graph, equation of a graph you have just plotted, just go and look for where does that graph cut the x-axis. Remember, anytime you solve a quadratic equation, the values you get are in terms of x. So just go and look for where does the graph cut my x-axis, and the two values there gives you the root of the equation. Now, looking at this graph, after plotting the graph, at what point do the graph cut the x-axis? At what point does this parabola cut the x-axis? If you see at this point, this is one point where it cuts the x-axis. The x-axis. Now you see between the point you have demarcated. So you still also have to find what does one line stands for in the x-axis. So we already found out what one line stands for in the y-axis. So in the x-axis, same thing. Remember the scale said what? 2 centimeters to 1 feet. That 2 centimeter means what? 10 lines. So 10 lines. But in this case, 10 lines is representing 1 unit and not 2. So what does that mean? 1 line will just represent 1 divided by 10, which is 0.1. So in the x-axis, each line is 0.1. So it's just left for you now to count how many lines. If you look at this, so okay, I can't expand above this. So if you look at this is like -1. Then I have 1 line, -1.1, and then the second line, -1.2, because at that point, that's where the graph cuts the x-axis at -1.2. So that is one of the solution to the root of this equation. Then coming this way, this is 1, the first line 1.1, the second line 1.2, the third 1.3, 1.4, 1.5, 1.6, and then 1.7. So from the graph, the root of this equation is just -1.2 and 1.7. So is this clear?
Yes, ma'am.
But ma,
Yes, ma'am.
please,
Okay. So yes.
Please ask the question.
Yes, who is asking a question?
please, is there any particular precaution we must take so that we make sure that we draw this curve very well?
Okay. What I can say, for example, now for a question like this, but I feel if you do it correctly, there will be no need for that, because normally they give a plus or minus for errors. You may not get exactly this value, but there is a space for some errors that can occur. But one other thing you can do is this. Fine, since you are given the quadratic equation, you can go ahead, that's if you are very fast and can maximize time, go ahead and solve this quadratic equation manually, either by factorization or by formula method, so that you get the x values. But I feel you only do that if you know you are very fast and can maximize time. Then you can come here and put the point where, for example, let's say as we solve that graph, we have the -1.2 and then the 1.7. So I will come, before I even join this point, I will come and locate that point. Okay, maybe let me use the previous ones. Let me use the previous graph to explain. Haven't put my point this way. If I have solved and I know that this graph, the solution to this graph is -1.2. So I'll come where -1.2 is, and I'll put a point there, just a small point there. Same thing, I'll come here where 1.7 is, and I'll put a point there, so that when I'm trying to join, I will make sure my point goes through that point. Do you get the idea now? So that I know that yes, I'm always correct. That's one way of also doing it, so that when I come to pick my roots, already I've put the point there and I made sure my graph passed through that point. Do you get? But if you go ahead and go and be solving it for them, it's going to be, even if the answer is correct, it's going to be a 0. Okay? And then the person marking will always check, even if you know maybe in your graph you found the root, but you now wrote the correct answer where that is different from what is in your graph, you also failed. So that's just a precaution you can take. If you can quickly solve it and then just come and put a point there and then join your graph. Is that clear?
Yes, ma'am. Thank you, ma'am.
Okay. Then going further for the question. So that is how to get the root. But be careful to look to be sure that the root you are asked, the root of the equation you are asked is the equation you have plotted. So as we go further, we'll see other questions where the equation they are asking for for you to find the root is actually different from the equation you plotted. So in such situations, we have to work on the graph. Now, the B part of the question says the value of x for which y increases as x increases. At what point is x increasing and y increasing? That is what this question is asking for. At what point is x increasing and y increasing? So if we look at our graph here, if you look at this, if I start from -4, okay, the graph started from -3. From -3, if you look at it, that's 17. It comes down to 6. It comes down to -1. It comes down to -4. Then if you see gradually, it starts once I come to 1, it starts increasing. The y value starts from -3. If I move this way, it comes to, is that at 2 it becomes 2, at 3 it becomes is that 11? Yes, 11. So what does that mean? Around this side, somewhere around this side, as x is increasing this way, y is increasing. But when I started from the negative side of x, as x is increasing, y value is decreasing. But somewhere around here, as x is increasing, y is also increasing. In fact, it continues to increase this way. So, but now we need to find that value of x such that after that called the turning point, because the graph starts like this and then immediately it turns. It starts increasing. Now, how do I know? Now, at that point at the graph turns, if I find there's what we call also the line of symmetry of a graph, line of symmetry. So sometimes they even say locate the line of symmetry of this graph. What is the line of symmetry of a graph? It's the line that divides your graph, your parabola, into two equal halves. So it's just a straight line this way that divides your graph equally. So at that point, at that point where that line of symmetry touches your graph, that is where it increases this way, and also this way it decreases. So, but how do you find this line of symmetry? The line that divides your graph into two. Now there's a formula that gives us that equation of line of symmetry. Note, for the kind of graph you'll be asked in WAEC, the equation of line of symmetry is always an equation of the x-axis. Okay, so for the graphs, either the graph looks this way or this way. These are the type of graph you may likely draw in WAEC. The equation of line of symmetry is always in terms of x. So that equation is given as x is equal to -b over 2a. What is your a and b? Remember, every quadratic equation can be written in this form: ax squared plus bx plus c. Okay, so your b is the coefficient of x, your a is the coefficient of a. So to get that equation, you just take -b, the value of the coefficient of x, divided by 2 times the coefficient of x squared. Is this clear?
No, ma.
No, ma.
Yes.
Okay, so what is not clear? Now, I know I'm deviating to talk about equation of line of symmetry, but why am I talking about that line? If I get the line that divides my graph into two equal parts, at that point of that line, where that line touches my axis, at that point, that is exactly when the graph starts to increase this way. Same thing, at that point, that is where the graph decreases this way. it decreases this way to that point. Then at that point, it also increases. So that point is like what divides the graph into two, such that the y, as x is increasing, the y is decreasing to that point. Same thing, as x is increasing here, the y is increasing this way. Do we understand what I'm saying?
Yes, ma, but how
Yes.
do we actually find the line?
Okay, so let's go back to our question. Now, if you, okay, I even have it here. Now, this is the equation we have just plotted. Y is equal to 2x squared minus x minus 4. So how do we find that equation? Remember, I said to get that equation, it is x, I've blocked this again. It is x is equal to negative b over 2a, right? So what will be my b value here? Remember, I say every equation can be written as ax squared plus bx plus c. So my b in this case is the coefficient of x. In this case, coefficient of x is what? Negative 1. So that's negative times negative 1 over 2 times my a value here is 2. So 2 times 2. So that gives me what? X is equal to 1 over 4. So at this point, x equals 1 over 4, that's 0.25. At this point, that is the turning point for my graph when x is 0.25. So if they ask you, if the question would have asked, locate the equation of line of symmetry on this graph, you just go to where x is 0.25, you draw the line. So is this clear now?
Yes, ma'am.
Yes, ma'am.
So,
Okay.
ma, at this
So now let's
0.25,
use, yes.
ma, at
Yes.
this 0.25, as x is increasing, y is decreasing.
What did I do? Sorry. At that 0.25, that's exactly where the graph turns. So at that point, it is neither increasing nor decreasing, if I will say that. But before this point, what happens? As x is increasing, y is decreasing this way. After this point, what happens? As x is increasing, y is also increasing. So that point, where will be 0.25? Let me try to expand this to see if you could see where 0.25 would be. Each line is 0. We concluded that each line is 0.1. So that would be 0.1, 0.2. That's like 2.5 lines. Let me see if we could locate 2.5 lines. So it should be somewhere here, in between here. Something like this. Ugh. So if you are told to locate it, this is what you're supposed to show on your graph, something like this. That's the line. Sorry, I may not get it. The graph is not that too clear. So if they had asked, if the question had asked, locate the line of symmetry, this is what they expect you to do. But for us, that's not even our focus. It's at that point. From that point going forward, y is increasing. So what does that mean? For what range of value will y increase? Starting from that point, whenever x is bigger than that 1 over 4, then x increases as y increases. Y increases as x increases. If they had asked, at one point is x increasing and y decreasing, you know you go the other way. Because at this point, as x is increasing this way, y is coming down, is decreasing. So that would just be what? Every value less than 1 over 4. So that should be x less than 1 over 4. So this region from here this way is x less than 1 over 4. And then this way, if you are going this way, it is x bigger than 1 over 4. Or the x value this way are bigger than 1 over 4. And those are the x values that gives us y increasing. Do we understand?
Yes.
Okay. So the answer to that question is x, all the x values bigger than 4. So what value of x for which y increases as x increases? Like we said, it keeps increasing. So it's just whenever x is bigger than 1 over 4. So how did we know this? We found the equation of line of symmetry. Then the C part says find the minimum point. How do you know the minimum point of your graph? Same thing, we use this idea of equation of line of symmetry. The minimum point is talking about what is the lowest point of my graph. What is the lowest point? Now, the lowest point is that point exactly from that line of symmetry. In fact, you can even find it. If somebody was asking what precaution can you take? Also, how do you know that your graph turns? But I don't really advise you to do that. Just make sure you draw the graph correctly, because that can also waste your time when trying to also make sure it follows the way it goes. Because you can, once you get the equation of line of symmetry to be, remember the equation of line of symmetry for this question is x is equal to 1 over 4. What does that mean? That is the point at which the graph divides into two equal parts. How do we know the minimum point? We talk about minimum point here because the graph is a U-shaped graph. If you have an N-shaped graph, you talk about maximum point. Here we can't talk about maximum point because the graph increases, it keeps increasing this way. Okay, so you can only talk about minimum point. Now, how do you know minimum point? A cheat way of doing it: impute this value into your graph. Whatever you get, that gives you your minimum point. So the minimum point is the y value from your equation of line of symmetry, from that line that divides your graph into two equal parts. Remember, this line that divides your graph into two equal parts is an equation in x. So if you go this way, the value of y, that's what gives you your minimum value. If somebody wants to, okay, so that I get it exactly, you can also put in the value of x equal to 1 over 4, get that value, and make sure, for example, if the value was supposed to be here, for example, I know that my graph, I will have to make sure my graph goes like this, something like that. So, but if you plot your graph correctly, you will always get it, because they give allowances for a little error. So if my graph is not too clear, but if I go by it, my minimum point will just be the lowest point. I told you if you have your line. So if you want to get it, just go where is x 0.25 we said. At that point, where you touch the graph, so trace the value of y. So that should be negative 4 point something, something, something. Is this clear?
No, ma'am.
Okay, what is not clear?
Ma, we're tracing the value of 0.25 to where?
I was just talking about if you want to be very sure of what the minimum value should be, you can take it and go and put it in the equation of the graph above. Y is equal to 2x squared minus x minus 4. But on a norm, even if you are putting that, you are not going to show that as a working. It will be marked wrong, because the question says from your graph. So what you are supposed to do is to come to the graph after locating where your line of symmetry is like that lowest point of your graph. At that lowest point, find the, for example, if this is the lowest point, how do I know the lowest point? The equation of line of symmetry tells me that. Now, even solving your equation of line of symmetry, you are not solving it in the question. You are just doing that aside to know that exact point. At that point, when you locate it, we said it was 0.25. At that point, where did it touch your graph? If it is somewhere here, then take the y value. The y value is your minimum value. Is it clear now? Or what
So,
is still
ma, in this
confusing
our
you?
graph,
Yes.
what is
Yes.
the minimum point here?
In this graph, the minimum point, if you look at the way we drew it, the minimum point should be negative 4 points. Now, it's not up to, we said on the x-axis, each line is 0.2. If you see, it's not up to this point. Our graph is not up to this point. So that's like negative 4.1. It's halfway between negative 4 and negative. The minimum point there is negative 4.1. Is that clear? So, like I said, if you want to be sure if you are correct, you can put it back into this equation. If you put it back, 2 into negative 0.25 squared minus 0.25 minus 4. What will this give us? Simplify this, what do we have? Yes, what do we have? Hello, are we together? Hello?
Yes, ma, we are together.
Okay, so when you imputed it, what did you get?
Ma, I'm a bit far from my calculator.
Hello? Can you hear me now?
Yes, ma.
Okay, so when you imputed the value negative 0.25, what did you get? Okay,
Okay,
so
so
is it my
for
network or
0.25
yours?
square times,
Hello, can
no,
everybody hear me?
0.25 square.
Yes, ma'am. Ma, I can't see your screen.
Hello, can you hear me now?
Yes, ma, we can hear you.
Hello, can you hear me?
Yes, ma, we can hear you.
Can anyone hear me?
Ma, can you hear us? We can hear you.
hear me? Please, can you hear me?
Yes, ma'am.
I think I'm audible now. Can anyone hear me?
Yes, ma'am. But ma, I can't see your screen again.
Yes, I wanted to be sure if you can hear me before sharing my screen. So let me share my screen now. So someone asked, how do we know exactly the minimum point? So like I said, it is just the lowest point of your graph, and the minimum point is always the y value. Okay? So like I said, a way of making sure you are correct, after getting your equation of line of symmetry, when you input this, I think you have, is it 4.12, something like that. So and that's in line with what we have in our graph here. If you draw your graph correctly, at that point of line of symmetry, tracing it, you have just negative 4.1. So is this clear? Any other question on this?
No, ma.
No, ma'am.
So can we go on?
Yes, ma'am.
Hello?
We can go on, ma'am.
Okay. So these are the answers from what we did. So the second question says we should copy and complete the table of values for y is equal to this. For now, the x value should range from 0 degrees to 180
Ma,
degrees.
ma, I have
Yes?
a bad network. I can't see your screen. I have a bad network. Are you still going to send the notes to the class group?
Okay, I can share the notes, no problem.
Okay, ma. Thank you, ma.
So, but others, can you see my screen?
Yes, ma.
Okay. So now to solve this, what you just need to do is, this is the equation given, and the x value should start from 0 to 180. In fact, they already told you how it should be in terms of 2020. The table was given this way. So it was left for you to now complete it. For example, to find the value of y when x is 20 degrees, what you need to do is just 3 sine 20 degrees plus 7 cos 20 degrees. So if you simplify this, that will give you, so for this you can just punch your calculator. Now if you see the values given to you in your table, you have it as 7.0, the next one 4.2, the next one minus 0.9. They put them in one decimal place. So if you punch this, most likely the decimal places will be more than one. But since they started giving you the values in just one decimal place, you approximate. So the values I have here, some of them are approximated values. So 7.6, 7.3, 6.1. So you approximate to just one decimal place. Is that clear?
Yes, ma.
Okay. Then this question now says, using a scale of 2 centimeters to 20 degrees on the x-axis and 2 centimeters to 2 units on the y-axis, draw that graph. So like I said, always use the scale, always look at the scale. 2 centimeters there means what? One of those big boxes. So if you are not sure, always you can measure, or just make sure that the 2 centimeters is 10 lines. So plotting this on our graph, this is the point. So if you can see on the x-axis, each of this is what gives me 2 centimeters. That's the 10 lines. So I started with 20 because they said 2 centimeters to 20 units. So since I started with 20, the rest will be additional 20s in terms of 20s. Then same thing on the y-axis, 2 centimeters to 2 units. So 2, 4, 6 like that. So both ways. Now I started this way because we don't have a negative x values, so that I can get to 180. So also know how to align your lines so that you don't have to now be looking for more space. For this, I don't have negative value, so that was why I started very close to the extreme end. So putting in all the values, now the first value was 7.0. So when x is 0, I'm at 7.0. Now, how do I know where 7.0 will be? This is 6 to 8, so I know 7 will be halfway between them. Or I go by saying I have 10 lines for 2 units, so that means one line will just be 2 divided by 10, which is 0.2. So each line is 0.2. Then the next point says what? For 20, I'm at 7.6. For 20, I'm at 7.6. So when I'm at 20, where will be 7.6? Remember, 7 is like 5 lines. Each line is 0.2, so this is 0.2. 7 is like 5 lines after 6. Then how do I get to 7.6? That will be one line more is 7.2. Another line more is 7.4. Another line is 7.6. So that's how I calculated that. So you must know what one line is to help you locate your point. The next one for 40 is 7.3. How do you get 7.3? From the fifth line, you have 7.0. The next line, 7.2. The next line, 7.4. What does that tell you? 7.3 with the 2 and 7.4. Is this clear?
Yes, ma'am.
Yes, ma'am.
Hello, is that clear?
Yes, ma'am, it is.
Hello, are we together?
Yes, ma'am, we are.
Yes, ma'am.
Hello?
Hello, ma'am.
Okay. So that's how all the points were located. So same thing when you get to, let me see the point. When you get to 4.2, okay, 4.2 is easy to locate. 6.1, it will be between 6 and 6.2. 4.2 can easily be located. 1.72, it will be between 1.6 and 1.8. Same thing, 0.9. So all those points that cannot be easily located will be between two lines. And so that's how we have the graph. So this is the plotted graph. Then the question that follows says, use the graph to find the value of y when x is 150 degrees. Now we need to find where 150 degrees will be. So same thing now on the x-axis, we need to find out what one line is. Same thing, we have 10 lines. 10 lines represent 20 units. So what will one line represent? One line will just be 20 divided by 10, which is 2. So each line is 2. So I want to get to 150. So 150 will definitely be after 140. So that will be how many lines to, if each line is 2, to get to 140, the first line will be 142, the next 144, the next 146, the next 148, and then the next 150. So that's like 5 lines after 140. So 5 lines after 140, if I count 1, 2, 3, 4, 5, I trace it down. Now, because if they say find the value of y when x is 150, I have to trace that value down. So 5 lines, this is 1, 2, 3, 4, 5. It may not be that accurate because I'm drawing 1, 2, 3, 4. So it's something like that. I have to follow that line until straight line, please. So until I get to this point, you see I put a black pen there so that we can see it until I get to this point. So on that point, what I do is to trace out the y value. So I draw a straight line from there using a straight edge, not freehand. I can't have access to a ruler. So you use a straight edge to go and get the y value. The y value is what gives you the value of y when x 150. Is this clear?
Yes, ma'am.
Yes.
Together? I know it's already 9, but I wanted us to wrap up this question so that tomorrow we'll start another question. So bringing it down and tracing it this way, the y value here is what gives us the value we are looking for. And that's negative 4.6. So if you trace it properly, that will give you negative 4.6. Then the B part of the question says find the range of value of x for which y is bigger than 0. For what value of x is the y values always bigger than 0? Now, if you look at the graph, same thing at some point, this graph is divided into 2. At this point, where we y, this is 0. From this point, where are the y values bigger than 0? If you see everywhere this way, the y values are bigger than 0 until you get to this point where your graph cuts the x-axis. After that, all the y values here are less than 0. So if we can get the point where this graph cuts our axis, then any x value less than that, value gives us what? Of course, the graph starts from 0. So any x value bigger than 0, bigger than or equal to 0, but less than that value gives us what? The range of value of x for which y is bigger than 0, because this is the part where we have values of y that are bigger than 0. So at that point, we just check. How do we check? We check. We already established that here one line is 3 units, 2 units, sorry. So we just count how many lines that gives us. So if we do that correctly, have that, and that is 13, no, not 13 now, that's like 6.5. If 2 lines is 2, so that's like 6.5. That's this point here. So is this clear?
No, ma'am.
Any question?
Ma, I didn't get you as you were explaining.
Hello?
Ma, can you hear me?
Yes?
I said I didn't get you as you were explaining it.
Okay, which of the question?
The last question.
The part of, okay. The last part of the question says, find the range of values of x for which y is bigger than 0. From the graph, at what point is the y values bigger than 0? If you start from the beginning, when x is 0, y is 7. That value is bigger than 0. When x is 20, y is 7 point something, bigger than 0. 40, bigger than 0. 60, the y value is bigger than 0. 80, the y value is bigger than 0. 100, the y value is also bigger than 0. But if you see any value after 100, still y is bigger than 0 until you come to this point where the graph cuts the x-axis. After that point, any point you pick is less than 0, the y value is less than 0. At 130, the y value is less than 0. 140, the y value is less than 0. 150 that we just found, y value is less than 0. 160, y value is less than 0, and so on. 180, y value is less than 0. In this range, we will always have a y value bigger than 0. So give us that range. That's what the question is saying. So that means at this point where this graph cuts the x-axis, from that point towards 0, all this region, any x value you pick really gives you a y value that is bigger than 0. Is that clear?
Yes, ma. But what would
Hello,
be
are we
our...
together?
Yes, ma. I understood the explanation. What would now be our answer?
Okay. So remember the x value started from what? 0 degrees. So 0 less or equal to x, less or equal to, we now find the exact point where this cuts our x-axis. So sorry, the graph is not too clear, but let's look at, let me expand it more. If you see, how many lines gives us that point where the graph cuts the x-axis? This is one line. This is 1, 2, 3, 4, 5, 6. It's not up to the 7th one. It's in between the 6th and the 7th. And what did we say each line is? We calculated already on the x-axis. Each line is 2. So this means this is 100 and this first one is 102, 104, 106, 108, 110, 112. Now, it is not up to 114. It is between them. So we say that's 113. So that will be 113 degrees. So this is our answer. Any value from here down, from between 0 and 113 degrees, the y value will always be above. It will always be a positive value. Then anything less than that, less than 113, sorry, bigger than 113 will now be a negative value. Is that clear? So this is your answer. Any x value you pick here. For example, 20 is between these two values. Once I pick 20, I'm going up. Y is positive. Once I pick 40, I'm going up. Y is positive. Do you get the idea now? So the exact answer is this. Is it clear now?
Yes, ma. Thank you, ma.
Okay. So tomorrow we'll try to solve more questions on graphs. So I'll try
please,
to,
that's very...
Okay,
or
ma.
maybe let's just wait. Yes?
Please, that first question table in that second question, was it part of the question?
Yes, this first table was given. So, but I
Okay.
just generated this after solving. So the first table was given. So that was why I said, since the values given were rounded to 1 decimal place, so every other one, you, like this table I have, you can go back and try it. They were the decimal, some of them, the decimals were more than 1 decimal place. But looking at the values they gave us, they put them in 1 decimal place. So they expect you that every other value you generate, you take it to 1 decimal. So they gave this table from the question. So when we come tomorrow, we would look at another graph and answer some questions under it. So just wait so that after tomorrow I can send you the slides after the class for tomorrow. So all of these are WAEC questions. I just extracted them from the past questions. So I'll see you tomorrow, same time.
Good
All
night,
right, bye bye,
ma'am.
everyone. Good night. Thank you.
Good night.
Good night.